This meeting is being recorded.
In section 8 of chapter 7, we're introduced to unimolecular reactions. These are going to be different now than what we saw before with bimolecular reactions, the SN2 and E2. Now we have an SN1 or unimolecular nucleophilic substitution, and then we have our unimolecular elimination. So they group these together in this section because they both have a common first step, which we'll see is generation of a carbocation. So we're asked to consider this reaction below, where we have both a substitution and elimination product. When we have this substrate in this solvent here. So these products are formed, we're said, when this reaction dissolves, right? The substrate rather dissolves. So our substrate is tertiary. So we know that a SN2 mechanism for substitution will not be possible. And our reagent, we're told here again, is ethanol. So this is not a strong base. So an E2 mechanism, we would say, is unlikely, or E2 elimination. So it turns out after this reaction is observed that first order kinetics confirms that neither SN2 nor E2 is occurring, and we could generalize the rate law for this equation to be, or for this reaction rather, to be the rate equals some constant K times the concentration of substrate. So that's the rate law that you should associate in general with any unimolecular reaction. So let's take a look at what that first step is when we have both SN1 and E1 reactions. So we have our tertiary alkyl halide here, and step 1 is the leaving group leaves, and we form this carbocation intermediate here. So this is the first step in what we'll refer to as a two-step mechanism. So again, the leaving group leaves, and that negative charge goes with it. So we're left with this positive carbocation. And then from there, we can proceed down this path, and a substitution reaction can occur or an elimination. So after the carbocation is formed, depending on how this carbocation reacts with the solvent, in this case, ethanol, we would have two possible products. So again, step 1, we have loss of that leaving group, which is commonly written over the arrow like so. So we have like a negative bromide ion. And then we see in step 2 a nucleophilic attack that occurs. And this lone pair on the ethanol is attacking this electrophilic site here. And we see in this step that when we have a neutral or nucleophile here, like ethanol is, we will have to have another proton transfer occur. So there's actually a third step here that is included in the second step in these two steps in the mechanism. So that's why we generally just say we have two steps, because the proton transfer is part of this nucleophilic attack, and it's more like a workup step to get our final product here. But we call these specifically solvolysis reactions because our nucleophile is also the solvent. So that's what we see with our ethanol here. So let's take a look at this reaction broken down in an energy diagram. So let's focus on here the highest energy transition state in an SN1 reaction is when we have this loss of leaving group. We can see that that's the highest energy. So this step here to generate our carbocation intermediate, we call the rate determining step, since it requires the most activation energy and the most energy to get to this transition state here. So when we talk about this first order reaction and the fact that the rate determining step is the formation of this carbocation. So this requires ionization of the substrate. So that's why we see a rate law for a first order reaction kinetics, specifically an SN1 reaction, that the rate will be equal to some constant times only the concentration of our substrate. So once again, just to make clear what these abbreviations stands for here, we have a substitution reaction. It is nucleophilic, and now the 1 designates that it is unimolecular. So the details of our SN1 mechanism, again, involves the loss of leaving group in a first step here. So we can generalize that as minus whatever halogen leaves with that negative charge. And left behind, we have this carbocation intermediate. And step 2, we have our nucleophilic attack. And we're told to remember that when the nucleophile is neutral, like it is in with an alcohol or water molecule, there will also be a proton transfer after the nucleophilic attack. So step 2B, if you will. And then we have our final product here, where that halogen was, or that leaving group in general. Now we have our nucleophile. So like so, we have with the E1 mechanism, we have our tertiary substrates with an alcohol solvent like ethanol. We have that two-step mechanism seen again. So we have our loss of leaving group here, and then what we refer to as a beta hydrogen elimination. So on our alpha carbon with the halogen, that's where the carbocation we see is generated. And then on this carbon here, we have that beta hydrogen that a lone pair on our solvent will grab that proton, and then we see that proton transfer here because of that neutral solvent acting as a base. We grab that proton, and then this double bond is created in our elimination product. So again, both of these mechanisms are unimolecular, so they follow the same kinetics. They have the same rate determining step. So once again, we have the same rate law seen for an elimination reaction. And our rate determining step is once again going to be that generation of that carbocation intermediate. So we will continue with a part 2 of this section in the next video.